This is Sudhavani. I would like to explain about dedicated interrupts. After going through this part of the lesson, you will be able to identify the types of dedicated interrupts, explain the uses of dedicated interrupts and their responses. There are 5 types of dedicated interrupts. Type 0, 1, 2, 3, 4. Type 0 is divide by 0 interrupt. Type 1 is single step interrupt. Type 2 is non-maskable interrupt. Type 3 is breakpoint interrupt. And type 4 is overflow interrupt. Now I would like to give type 0 interrupt in detail. So that is occurred due to the division operation. There are 2 types of division operations for 8086. One is div and another one is idiv instruction. When this divide by 0 interrupt happens, there are 2 reasons. Whenever the quotient from a div or idiv is too large to fit in the result register, or whenever the divisor is 0. Here is the numerical example that 570 is loaded in AX register and 02 is loaded in BL register. So after execution of this div BL instruction, if we examine the AL contents 29, we can observe that actual quotient value obtained if you divide 570 by 2, that is 285. But the result register, that is nothing but quotient register, which is small to accommodate this 285, thereby divide by 0 interrupt occurs for this 16-bit by 8-bit division operation. This is the interrupt response of divide by 0 interrupt. Here these are the common steps for the response of the interrupt by 8086. The 8086 gets the new IP value from 00 and 01H memory locations and a new CS value from 02 and 03 memory locations. That means the starting address of this divide by 0 interrupt service routine is available in these memory locations. Like that it executes that ISR. The second interrupt is type 1 interrupt, which is also called as single step interrupt. What is the use of this interrupt? The main use is for debugging the programs. It executes one instruction at a time and stop. Thereby we can examine the contents of registers and memory locations. If the result is wrong, then again we can modify the program instructions and again we can use this single step operation. Type 1 interrupt. Here how to set and reset the trap flag. The program segment will give you the setting of the trap flag. Push F, move BP, SP, or operation with the contents of the address where the BP is given and with the 0100. And pop F is again that flag register contents are restored. This is the program segment to reset the trap flag. Only change in the AND instruction with the contents of FE, FFH and the contents of the memory location whose address is available in BP register. This is the interrupt response of single step interrupt. The ISR is available from these memory locations which is written for single step interrupt. Third interrupt is type 2, which is non-maskable interrupt. So why the term non-maskable? It cannot be disabled by any program instructions and it cannot be disabled by accidentally or intentionally. You can use INT2 in the program to execute this type 2 interrupt. Here this is the interrupt response of non-maskable interrupt. The ISR written for non-maskable can be obtained from these locations of interrupt vector table. This is an example to give you why this interrupt is non-maskable interrupt. The pressure checking of steam from the boiler. What is the response of this 8086 if pressure exceeds some limit? Pressure sensor on a large steam boiler is connected to the NMI input of 8086 processor. If the pressure exceeds some preset value, the pressure sensor will send an interrupt signal to the 8086 through NMI. This ISR written for it might turn off the fuel to the boiler, open a pressure relief valve and sounds an alarm. The events that should be addressed immediately by 8086 are written as NMI ISR. Fourth interrupt is type 3 interrupt, that is breakpoint interrupt. What is the use of this interrupt? To implement a breakpoint function in a system. This is also can be used for debugging of the program. Suppose if you have written 200 lines code of 8086, for every 10 instructions you can, if you want to examine the contents of registers and memory locations, you can examine by inserting int 3 instruction. So 8086 executes the instructions up to the int 3 instruction. Like that you can place this int 3 after 20 instructions, 30 instructions, like that. This is the interrupt response of breakpoint interrupt. These are the common steps. The starting address of the ISR written for this breakpoint interrupt is available from these memory locations of interrupt vector table. Fifth interrupt is type 4 interrupt. This is also called as overflow interrupt. When this overflow interrupt happens, if the result of the signed arithmetic operation is too large to fit in the destination result or memory location, the OA flag will be set. You know that if MSB is 0, that is called as positive number, and if MSB is 1, that is called as negative number. Here we are loading two positive numbers in AL and BL. After using this add AL and BL instruction, the sum is available in AL, but after execution of this instruction, if you examine AL contents, you get this minus 62. That is not correct. If you add two positive numbers, the result should be positive. Thereby, we say that this result is not correct. Then the overflow flag will be set. How to check the overflow error? There are two ways. One is writing JO instruction after add AL, BL, and the second one is writing INTO instruction after add AL, BL. So the SR routine we can write in such a way that it gives the message as overflow error occurred. This is the interrupt response of overflow interrupt. These are the addresses to get the starting address of the ISR routine written for the overflow interrupt. This is the summary. There are 5 dedicated interrupts. Each interrupt is used for specific purpose, and starting addresses of ISRs written for these are available in interrupt vector table. In this, NMI is hardware interrupt out of all 5 dedicated interrupts, and remaining are called as software interrupts. Thank you.